Have you ever stopped and wondered what's really going on inside the mind of an AI like ChatGPT? For the longest time, we've kind of treated it like a black box. We see what goes in, we see what comes out. But that whole middle part, total mystery. Well, thanks to some really fascinating new research, we're finally prying that box open. And what we're finding inside is seriously challenging a big assumption we've had about how these AIs actually think.
So there's been this idea floating around in the AI world for a while. The deeper you go into a language model, the less important the layers get. The common wisdom was that these later layers were, well, kind of redundant, just adding extra weight without much of a real benefit. But as it turns out, that might not be the whole story. Not even close.
So on one side, you have the old, simple view, more layers, less importance. It just kind of fades out. But this new discovery, it completely flips that idea on its head. It turns out, importance has nothing to do with depth. It's all about the task. Different layers have incredibly specialized jobs. So you see, it's not just a stack of clones. It's a team of specialists. Probably the best way to get a handle on this is with an analogy. So let's stop thinking of a large language model as one big, uniform computer program. Instead, let's imagine it's a layered brain, where different regions are responsible for totally different kinds of thinking.
Okay, our tour of this AI brain is going to start with the shallow layers. That's the very first part that gets to work on your prompt. For a long time, their exact job was a little fuzzy. But now we know they have a very specific and absolutely vital function.
The research is crystal clear on this. These first few layers are the masters of knowledge. Their number one job is to remember and pull up facts. You can think of them as the AI's long-term memory.
And here's the cold, hard data to prove it. Researchers tested a model on how well it could recall simple facts. With the full model, performance is obviously great. Now, if you take out the deep layers but keep the shallow ones, it still performs at 99%. But look what happens when you remove those shallow layers. Performance just plummets by 80%. That is a massive, massive drop.
So it's pretty simple when you think about it this way. These shallow layers are the bedrock of the model's knowledge. They are its memory bank, holding onto and instantly accessing this huge library of facts it was trained on. Take them away and the AI basically gets amnesia.
All right, so if the shallow layers are handling memory, what about the rest of the brain? This is where we go beyond just simple recall and get into something way more complex, actual reasoning.
And this is where things get really, really interesting. The deeper layers, they aren't just repeating what they know. Their specialty is connecting the dots, using facts to tackle complex, multi-step problems, like solving a tricky math problem or following a logical argument. This is where the real thinking happens.
And the data here tells a completely different story. When you test the model on math problems that need step-by-step logic, taking out the shallow memory layers only causes a small dip. But, and this is the key part, when you take out the deep layers, performance craters. It drops by 60%. This just goes to show you, for complex reasoning, those deep layers are absolutely essential.
This really nails down our brain analogy. The deep layers are the AI's logic center. They take all that information from the shallow layers, and then they go to work, connecting ideas, following steps, and, actually solving the problem. So we've got a memory center and we've got a logic center. What this really means is that it's not about which layers are better or more important. The real takeaway here is that the right tool, or in this case the right layer, depends completely on the job you're asking it to do. This table just sums it all up perfectly. For something simple like fact retrieval or a common sense question, the shallow layers, our memory center, are the star of the show. But for math or for generating a long, coherent story, you absolutely need those middle and deep layers, the logic and language centers, to be firing on all cylinders. Each task lights up a different part of the AI's brain. And just when you think you've got it all figured out, the research throws another curveball. It turns out this specialization gets even more specific. It doesn't just happen between the layers, it happens within the layers themselves. See, inside each layer, you've got these little components called attention heads, and you can think of them as mini specialists. Some are total pros at retrieving facts, while others are absolute wizards at reasoning. And their impact? It's staggering. Get this, the research found that removing just one single critical reasoning head could cause math performance to drop by 60%. One tiny component.
So, okay, this is all very cool, but why does any of this matter? Why is understanding this internal division of labor so important? Well, because it's the key to building better, smarter, and way more efficient AI in the future. So let's recap the big ideas here. First, those LLM layers aren't redundant at all. They're highly specialized. Second, shallow layers are for memory. Deep layers are for reasoning. Simple as that. And finally, knowing this stuff helps us build smarter AI. We can now actually target specific layers to make models smaller, faster, and more efficient without losing their power.
So when you really pull back the curtain, you start to realize that a large language model isn't just a brute force stack of identical parts piled one on top of the other.
It's actually a sophisticated, highly organized team of specialists. Each one has a unique role, and they're all working together to create the incredible results that we see.
You know, this discovery fundamentally changes how we look at these models, and it leaves us with a really fascinating final thought. We've just uncovered this split between memory and reasoning. So as these models get even more complex, what other hidden specialists are just waiting to be discovered inside their ever-evolving digital minds?